You're welcome to Module 5 of our Chapter 1 Introduction to Algebraic Expressions. But before we move on, we're going to be dealing with the corrections to the previous exercise on Module 4. In Module 5, we're going to be treating inequalities. That's what we're going to be treating. We're going to be solving inequalities. And it's just like the same equations that you've been solving using the equal to sign. So wherever you see the equal to sign, an inequality comes with a greater than or a less than. A greater than or a less than sign. And when you relate these things together, you get inequality. Let us touch this day 4, the module 4, for solving two-step equations and all the exercises that it entails. For the first one, the exercise says we should solve 4x plus 5 equals 21. And as we know it, we're going to make plus 5 subject to x subject to formula and move plus 5 to the other side of the equation. And after doing that, we're going to be left with 4x equals 21. The sign changes, minus 5. And this becomes what? 4x equals 21 minus 5, 16. And then we're going to divide both sides by 4 in order to make x subject to formula. X equals 4. If you got that, well done. For the next equation, it says 2y minus 7 equals 9. For the next equation, it says 2y minus 7 equals 9. We understand we want to make y subject to formula, so we move minus 7 to the other side, and we are left with 2y equals 7. Sorry, that's meant to be 9. 9 plus 7. The sign changes. And this is 2y equals 16. And how do we make y subject to formula? By dividing both sides by 2. And when we do that, we have 2y equals 16 divided by both sides by 2. Our y is equal to 8. If you got that, well done. All right, we move to the next question. That question says 6m plus 2 equals 20. So we're going to move 2 to the other side so that 6m can stand on its own. We're going to have 6m equals 20 minus 2. 6m now be equal to 18. And so how do we make m stand on its own? The same thing. We divide both sides by what? Exactly, by 6. We'll divide both sides by 6. Our m equals 18 divided by 6, and that is equal to 3. You got that? Well done. The next question says 7n minus 3 equals 25. Now we're going to move minus 3 to the other side because we want 7n to stand on its own. We're going to have 7n equals 25 plus 3. 7n, therefore, equals 28. And so how do we make n? Subject to formula. Divide both sides by 7 so that n can stand on its own, and n is equal to 3. Sorry, that is 4. So if you got that, well done. And for the next one, it says 3p. The last one, it says 3p plus 4 equals 19. So 3p equals 19 minus 4, and 3p will be equal to 15. And how do we make p stand on its own? Divide both sides. Sorry, divide both sides by 3. So p equals 5. If you got that as well, well done. All right. Now that we've got to the hang of all the exercises we've done so far from Module 1 to Module 4, let us go straight into our Module 5 for today. Remember, this is just the basics of the algebraic expressions, or the introduction to algebraic expressions. You will be getting to algebraic expressions 2, and that is in the chapter 2, where things will get more advanced and where we can see how we use these algebra or algebraic expressions in a normal day of our lives and also programming. But for now, let's get on. For the exercises that was dropped, your Google Classroom, you're going to see a document that entails all the corrections to all the 100 questions that was given during the course of Friday down to Saturday. When you see the corrections, you are to compare these corrections to the exercises that you saw, all 100 questions that were to be answered. After comparison, you can test yourself to see how well you are in algebraic expressions. Let's head on to Module 5. Solving inequalities. What are the objectives we're going to be having here in Module 5? The objectives are solve and graph simple inequalities. That's what we're going to be doing. Solving and graphing simple inequalities. Let's check worked examples, shall we? All right. For the first question, it says solve x plus 3 greater than 7. Now let us understand something about this called inequalities. Inequalities. Let's understand. Now, it follows a greater than sign or a less than sign. It follows a greater than sign or a less than sign. Or it follows a greater than or equal to and a less than or equal to sign. This is greater than or equal to, and this is less than or equal to. So greater than or equal to, less than or equal to sign. Fantastic, isn't it? Let us solve and see how we can apply inequalities in this equation. For the first question, it says solve x plus 3 greater than 7. It means simply that we want to move or make x the subject of formula. So just like you're having the equal to sign, remember, whenever you see an inequality, it also means equal to. Whenever you see an inequality, it also means equal to. All right, let us solve. Now, all I need to do is move this big guy here, and I'll be left with what? X greater than 7 minus 3. Therefore, x is greater than 4. And that is my answer. That is quite easy, isn't it? It's a simple mathematical arithmetic. That is quite easy. Just think of the inequality as an equal to sign, and you have no problem. Next question. In the worked examples, it says we should solve 2y is less than 10. Remember, it says 2y is less than 10. The same thing I'm going to be dealing with the equal to sign. Remember, just take this as an equal to sign. All right? So this is the same as writing 2y equals to 10. And we can solve by doing what? Dividing both sides by 2, and our y will be equal to 5. But when it comes to inequalities, we use the inequality sign. So instead, we're going to have, when we divide both sides by 2, y will be less than 5. That's the value, and that's the answer. Y is less than 5. Let us check the next question. This has to do with critical thinking, so pay attention. It says 7 minus 5 is greater than or equal to 3. Now, whenever we have an equation as this, greater than or equal to is trying to tell us one thing. It's telling us that it is a closed statement. It is a closed statement. When you do not have the sign beneath, it is an open statement. It's an open statement. So we have closed statements. We also have open statements. Now, this is trying to tell us that 7 minus 5 is greater than or equal to 3. So let's check how true that is. 7 minus 5 is 2, greater than or equal to 3. This is not true. This is false. Why is it false? Because 2 is not greater than, neither is it equal to 3. Therefore, that equation is a false equation. We term it as a false equation. Are you understand? Now, let me just explain a little bit about inequalities so that you can understand one thing about the number line systems that involves inequalities. Let's take this to be our graph. And this is the origin of the graph. At the origin of the graph, we have our 0 at the origin. Then the graph has its x-axis, at this part is our positive values of x, and at this part is the negative values of x. Now, if x reads for one value, it means when I say 1 unit or one value, it means for every value I add 1, 1, 2, 3, and so on. For the negative part, it's going to be minus 1, minus 2, minus 3. Now, let's talk about inequalities and what inequalities has to do with these graphs. First off, when I say something like this, when I say x is greater than or equal to 2, what I mean is that x starts from this range. You can see that it is colored. Why is it colored? And x is moving this way. This sign you see here indicates that x is greater than 2 and it is also equal to 2. That's what this statement is talking about. That's a true statement. Okay? It's a closed statement. It's closed, it's complete. It's not an open statement, it's true. So x is equal to 2, all right, and greater than 2. X is greater than or equal to 2. That's the interpretation on a number line. Now, what if we have something like this? just x greater than 2. Then, in order for me to do this, I will just have an empty circle on it, not shaded. The interpretation is what? X is greater than 2, but it is not equal to 2. So that means x ranges from 3 upward. But for this, it means I'm going to shade it. This means that x starts from 2, 3, and so on. That's one thing about the inequalities you need to understand about the closed statements, which are the true statements, and the open statements, which are incomplete, where you do not have greater than or equal to or less than or equal to sign. Having said that, due to the programs, we move forward. We move into the introduction to what problems with algebra, and this is Module 6. Welcome to Module 6. Introduction to what problems in algebra. Let us check our objectives. For the first objective, we have convert what problems into algebraic expressions. And the second thing students will be learning is solving real-life algebra problems. Let's head on. For the first example, it says, the number increased by 5 is 12. Find the number. This has to do with critical thinking. Remember, this is just the basics of algebra. We are getting ahead. So, chapter 2. Let's work this out, shall we? Let that number be x. We said it is increased. Remember module 2 when we dealt with this? Increased by 5, and they said it is equal to 12. A number increased by 5 is equal to 12. Is 12. Find the number. So what we're going to do is take this little guy to the side. We're going to have what? X equals 12 minus 5, and what? X will be equal to what? 7. So that means the number is 7. And if you check the statement, 7 increased by 5 is actually 12. So we can as well understand the critical thinking on that. 7 increased by 5 is 12. Alright, let's check the next example, shall we? For the next one, it says, twice a number plus 3 equals 15. Find the number. Same thing, same trick. Let the number be x. So when we have twice a number, it means 2x plus 3. They said it is equal to 15. We want to make x stand on its own. We take this little guy to the side. We're going to have 2x equals 15 minus 3. And this becomes 2x equals 12. And you know what to do. Divide both sides by the coefficient, and that is 2. And when we cut it through, x is equal to 6. Twice the number plus 3 equals 15. Our number is 6. If we multiply 6 by 2, which is twice of 6, that is 12, and we add it to 3, is equal to 15. This verifies the statement. Are you with me? Clearly, let's check the third example, shall we? Sorry about that. Alright, it says a father is 3 times as old as his son. If the son's age is 8, find the father's age. Fantastic algebra. Fantastic. So let the father's age be x. We do not know the father's age. But I said he's 3 times as old as the son. His son's age is 8. Son's age is 8. The father is what? 3 times as old as the son. Therefore, the father is 24 years. That was quite easy. That was quite easy, isn't it? Mind you might see exercises that are quite different from this. But just try to use your critical thinking. And before you move into chapter 2 of our mathematics club, you're going to be faced with a 200-page document, a 200 question document exercise, meaning that you're going to answer all these exercises just to train yourself. It is a compulsory task that you must do on your own, aside dealing with your normal graded assignment. This is ungraded. You must do it on your own because questions such as this that will be coming up within your quarter exams come in. Moving forward, this is the end of chapter 1. If you made it to Module 6, I congratulate you. Now you've understood the basics of algebraic expressions and the introduction that it deals with. And so we move in our journey to chapter 2. And in chapter 2, we're going to be dealing with advanced algebra. Thank you. Remember, your exercises for Module 4, Module 5, Module 6 are in the Google Classroom. See you next time.